All right, so we're going to talk about 6.3, which is exponential and stepping now into logarithms. So I want to start here by just showing you this is the formal equation for exponential. And so it looks a little like this, if I see an exponential, okay? All right, now we're going to be talking about logarithmic equations. And so this is how we would write a logarithmic equation. We're going to talk about that. But I want you to recognize that these two things, this exponential and this logarithmic equation, are equivalent. They're just written in two different ways. All right, so when we look at something exponential and something logarithmic, they are inverses of each other. And we've talked a little bit about inverses. Notice our x and y in our equations. So the purpose of having logarithms is they're pretty much defined as solutions to exponential equations. So that's how we eventually are going to solve an exponential equation. All right, so you need to take a little bit of time to talk about them first. But first of all, I just want to be sure that you can write them in the correct form. So I kind of started with this right here. All right, so here's our exponential. We're going to write it in logarithmic form. Again, they're equivalent, how they're written. All right, so 2 to the x equals 32. All right, so 2 is your base. That's important to recognize that 2 is your base, x is your power. Okay, we want to say 2 to what power equals 32? That's kind of what this question is. What is x? Well, let's look over here, but before we solve it, let's just learn how to write it. So we're going to, first of all, when we do our logarithm, notice this is y. So this is your exponent. Whatever your exponent is here, that's going to come down. So here's the exponent. That's what goes on this side of the equal sign, equals log. Okay, you're always just going to have log. And we'll talk about a natural log later. Log, and then here's your base. Well, the base is 2, right? So we're going to put a 2 here. And then we have 32. So really, this 32 and this x are going to switch sides when we write them as logarithms. So let's take a look at this one. So 2 to the 5th equals 32. So we're going to bring the power over, equals our log of whatever the base is, which is 2, 32. So that's just kind of rewriting them. All right, so now we're going to talk a little bit about how to solve that. So let's say we're given a logarithm. Let's say log base x of 16 equals 4, something like that. All right, well, we want to figure out how to solve that. So we want to, we want to solve that for x. So we are able to take that and put it into an exponential equation. So we're going to work it backwards. So we're going to look at this exponential. So remember, we want to know what is the base. Well, the base is x, so we're going to take x, and then we're going to switch sides here. So x, here's your power, equals 16. And it just takes a little bit of time to just get that figured out. Once you get it down, it'll be easy. But the base to the power, this is your exponent, equals 16. Now we want to finish solving that. So how do you, we want to make this 1. So what would I multiply that to make it 1? Well, would you agree it'd be 1/4? So 1/4 is the same thing as the 4th root. So what we would normally do with this is we would do the 4th root because it cancels that out. But what we do to one side, we have to also do to this side. So then the question is, well, what is the 4th root of 16? So you can put that into your calculators. All right, and so the 4th root of 16 would be 2. So the answer there is x equals 2. I'll just put equals x. All right, so x equals 2 for that. All right, so how about this one? This one might be a little bit more. So log base 4 of x equals 3/2. This one's a little bit more, but you're still doing the exact same process. So let's go ahead and take, okay, what is the base here? Well, the base is 4, right? So 4, here's your exponent, to the 3/2 equals x. So you could just put that into your calculator. And what that really is that's going to be this, remember this is the power and this is the root. So it's the square root of 4 to the 3rd. 4 to the 3rd is 64. So that's going to be 8. Now you can just put that into your calculator. That's fine. And you'll get that x equals 8. Okay. All right. Now, sometimes though, now this is solving an equation, right? So this right here would be solving. Now here we just want to simplify. So there's not going to be an equal sign in that because we're not solving it. So the question here would be something to the effect of, let's say log, let's do base 3 of 81. Okay, it just says simplify that. So it's not written as an equation, but what the question is 3 to what power is going to get me 81? So this is what it's saying. It doesn't show it because we're not using an equal sign right in it. But just to show you what the question really is asking, it's saying 3 to what power is 81? That's the question that's asked. So 3 to what power is 81? Well, is it 3 times 3, 9, 24? 3 to the 4th? So the answer here is 4. But you're not given this. That's just what it's really asking you when you look at this. So if I had, how about I just do log base 2 of 8? Can you kind of in your head think about that? 2 to what power equals 8? And that's going to be what? 3. So it's saying 2 to what power equals 8? Well, that's 3. So again, you're not expected to write this. It's just that's what this is asking. What about something like this? What about log base 3 of, let's do 1/3. Let's do a fraction. Okay, so that simplifying is saying 3 to what power is 1/3. So 3 to what power is 1/3? Well, recognize if this is a negative, right, that moves this number down to the denominator. So if I were to make that a -1, then 3 to the -1, wouldn't that be 1/3? Because we'd move it to the denominator. So that also works when we have fractions to simplify. All right, so let's talk about the common logarithm. So a common logarithm, okay, that's when we are dealing with base 10. All right, and so when we talk about a common logarithm, and I have it written like this, something like this, notice that I don't have a base showing right here, and it's a log, but I don't have a base. Like up here, I have a base showing, here's 2, here's 3. I don't have a base. So if there's one that's not showing, you naturally assume it's a base 10. So you assume that that's going to be a 10. So that's the same thing as this. They just don't show the 10, and that's a common logarithm. All right, and so logarithms are used when we just are using big numbers, right? So, you know, when we do any kind of growth or decay or, you know, like even sound like decibels or maybe a Richter scale for when we have earthquakes. You know, those are big numbers that we're dealing with. And so that is a lot of times when we use a common logarithm. And we also, our decimal system is built around base 10. So that's why we have common logarithms, and we use all different kinds of logarithms, but this one, when we use this, recognize if there's not a base showing, it's a 10, all right? So you can evaluate these with your calculator. Your calculators are built for base 10. Now, some of the newer ones, you can put in a different base, but I just wanted to show you here on, I'll just show you on Desmos, because that's the easiest thing for me to show you here. Let me see where I have it. So here's just the Desmos. Okay. So on the keyboard, so what I'm going to try and do is I'm going to find what is, let's see, let's do the log of 12. I'll write this on the paper so it'll be on there when we come back to the notes. So the log of 12. So log 12, I didn't say a base, so that means it's a common logarithm, it's a base 10. So, and that's what the calculators have here. They're automatically base 10, so you don't have to worry about it. So how I find that on here on Desmos is I go to functions and then over here to miscellaneous. And here's your log. Okay, here's your natural log that we'll talk about a little bit later. So here's, well, actually here's a log with a base, but we're not gonna, I'm gonna show you something different other than that. So let's just look at this common logarithm. I didn't know that it had that on there actually. All right, so log 12. So it's approximately 1.08. All right, so it's approximately what it would be. But you notice how If I had if I had a 10 here showing or whatever it is, I don't know 10 to what power equals 12. I don't know that. That's not one I could figure out in my head, like 2 to what power is 8. I knew that that was 3. This particular one, I know this is a 10, and I'm saying, I don't know 10 to what power would give me 12, but it's going to be approximately 1.08. All right, so if many of these you just do on your calculator for the logs. So let's do what would maybe be the log of 0.1. So I'm writing these on your notes as I do this, so you'll have them on here. So the log of 0.1, again, just go over here to functions, go to miscellaneous to log, and let's just do 0.1. So that's not what I want. Let me try and get a better picture here in just a second. Move that up a little. All right, let me erase that. Here's my decimal, so 0.1. And that answer is exact -1. All right, so that equals a -1. I want to take you back here for just a second and show you the notes. So this is -1. I want you to think about that, because would you agree that 0.1 equals 1/10, right? And so 10 to what power gives you this 1/10? Well, it's to the -1 power. So that equals 10 to the -1. So that's kind of what this question is saying. It's saying, all right, what is the log of 1/10? So power of 10, and 10 to what power is going to give you this? Well, I move the 10 to the denominator, so it's a -1. So the answer is -1. Does that make sense a little bit? So that one you could actually do paper pencil. You don't have to have the calculator for that. All right, so how about this one? Let's look at this log of 3/5. Let's do 3/5. Let's use a fraction in here. Okay, log of 3/5. So we'll go back here and let's do again our log, and we'll do 3/5. 3 divided by 5, and it's a negative approximately 0.22. We just went, so that, okay. All right. So now let's talk a little bit about a natural logarithm. So I'm going to take you back here to my notes. All right, so let me move my camera a little bit. All right, so we talked about the common logarithm. Okay, now there's also a natural logarithm. All right, and natural logarithms where the common is a base 10, right? The natural is a base of e. Do you remember when we did the base of e and like the compounding interest, right? That is an irrational number, approximately 2.72, but it just means that we were compounding continuously, right? So for the base of e, what we would use here is we would use what's called a natural logarithm, and that's called L of n. That's what that is. It's an ln, but it's L of n of x. So the natural log of x. So notice, again, just like the common logarithm, there's nothing showing here. So I automatically assume that's an e rather than a 10. All right, so it kind of depends on what kind of logarithm you're using on what you're doing. But if it's like a decimal type number that you work in decimals, you can use a common logarithm. Base 2 would be used in some of your computers, right? When you do your programming, things like that have base 2. But there's really no use for some bases that are very rarely used, like maybe a base 7. So really the purpose of that is just learning about bases and being able to convert bases to numbers. But not all of those are really used very often. But base 10 is used a lot, base 2, and the natural world, we use a lot of base e with continuous, with just being continuous growth, right? For example, when we talk about E, that E is a continuous growth, right? We talked about compounding continuous growth. So the natural log is the inverse of E. Okay, the natural log is the inverse of E. So just to kind of get this straight in your head, that's why I'm kind of telling you about it. So let's say we had So if I just want to talk about E, all right, just to give you a little hint here, E would be maybe, let's say we're going to put in time, just kind of making this up here, time to get growth. All right, so whatever it is, I'm going to put in time so I can get growth. Well, the natural log then is the inverse of that. So it's going to say, all right, I'm going to plug in growth to get time. And E deals a lot with growth because it's continuous growth. Okay, it's growing continuously, it's growing exponentially. And so that's just to kind of give you an idea of why we use that base E with the natural logarithm, because they're inverses of each other. All right, but on a calculator, it's not any different. You just have to use the natural log. So we're going to find the natural log of 10, and we can use that on our Desmos again. So here, let's just do, let's go down here to our functions, and here's the natural log. And we can just type in a 10 there. And we'll see it's approximately 2.30. Okay. Let's see, approximately, I'm writing this on your notes so we have it. How about we do the natural log of, E, just to kind of see what that is. Let's see, natural log. I said that, and then I'm not sure where to find the E at here. Let's see, it's probably under functions. Okay, well, folks, let me look here. Pretty sure we don't use this E here. All right, well, I guess because I can't find it, we know it's approximately 2.72, right? That's approximately what it is. So it's approximately 1. Natural log of E is 1. Right. And so that's saying if I had an E here showing, E to what power gets me to approximately 2.72? Well, E to the first power, because E is approximately 2.72. All right, I hope that's kind of making sense. All right, so let's get back here to our notes. So there's some ideas on natural logarithms and common logarithms. So on your notes here, I want to talk a little bit now about, we're going to get to the point where we're going to start studying how to solve logarithms, all right? But in order to do that, there's some properties that we have to always follow, which are rules that we follow to solve them. So we want to talk about the properties of logarithms. So first of all, we have the product rule. And we know that product means multiply. All right, so that means if I have, for example, a log of some base, I'm just going to use base A, okay, doesn't matter, just of some base, and then I have xy. So what you have to recognize is that this is a multiplication. So if it's a multiplication, x times y, I have to use the product rule. And what this is going to do is it's going to help us expand the problem so that later we'll be able to solve it. All right, so this is just a step in the process of solving. So how I would rewrite that is I would rewrite that as log base A of x plus log base A of y. So when you have the product rule, you're going to take what you're multiplying and you're going to add it together. All right, so that's just one step in the process. So I'm going to go through the 3 rules with you, and then we'll do some problems to kind of go through them. So then we also have the quotient rule. Well, you know, quotient means divide. All right, so if we have something like the log, again, we'll just use base A of x over y. All right, well, when we have a division problem, how we're going to expand that is using a subtraction. And so we're going to take the numerator, log A base A of x, minus log base A of y. So we're going to use a subtraction to expand this. So eventually we can, you'll see later, start solving those. And then lastly, we have the power rule. So the power rule, if you remember, deals with exponents. Given log base A of x, let's just take it to a power of r. Well, to expand that, we're going to bring this exponent, we're going to bring it down to the very front before your log. So we're going to have r log base a. And that's how you, of x, sorry, forgot my x there. So all I did was bring this to the front. All right, so you need to know those. You need to know that the product goes with addition, quotient goes with subtraction, and the power rule brings that to the front as kind of like a coefficient in front of that. All right, so let's say we have log, let's do a couple examples here. Say we have log of 8x. So I'm just going to ask you to write that in expanded form. All right, so notice what basis would be. This is a common logarithm because it's base 10. So I go ahead and I, because it's a multiplication, we're going to do addition. So we're going to have log of 8 plus log of x. Okay, expanded form. All right, what about this? Let's say we have log base 9 of 15/7. And I'll put here that we are putting these in expanded form. All right. So here, notice this is a quotient. So that means we're going to use subtraction. So log base 9 of 15, remember the numerator goes first. That is important. Minus the log base 9 of 7. How about this one? Let's do log. And you might want to just shut the pause for a minute and try and figure it out. Let's say we have this. So whenever you have a radical, whatever kind of root it is, you want to, first of all, write that as an exponent. All right, so let's begin that by rewriting the problem. And remember, if this is a square root, that's a 2, so it's 1/2 to the 1/2. If it's a cubed root, it's 1/3. If it's a fifth root, it's 1/5. Okay. So start by writing an exponential. Well, once you have it in exponential, then that's pretty common because now it's dealing with the power, right? We now have a power here. So we're going to use our power rule. So what we're going to do from there is we're going to bring our exponent to the front as a coefficient. So 1/2 log base 5 of 8. All right. Let's see, how about, let me give you one here to try. Let's say we had this, so we're gonna maybe put a combination together here. Log base A, let's take x over yz. Now, if you wanna pause this and try it and come back, let's go ahead and I'll go ahead and solve it. So first of all, we notice that we have a division and we also have a multiplication, right? So I'm going to start by writing the, we're going to do the quotient because that's a division to begin with. So our quotient rule, if you remember, is subtraction right here. So we're going to take log A of x, log base A of x, minus. Now notice down here, I'm going to have a multiplication. So I'm going to go ahead and put a parenthesis here because I have a multiplication. And remember then our multiplication, when we expand it, is addition, right? So let's rewrite, again, we just put a log base A in front of each of those. So we have y plus log base A of z. Now to completely simplify that, you want to go ahead and multiply that negative through right here. All right, so the final answer here would be log base A of x minus log base A of y. And notice that then becomes a negative log base A of z. And that would be completely simplified. But notice if I didn't put the parentheses in here, then you wouldn't know you need to distribute that through. So you're going to get the wrong answer. So that's why it's really important if you have multiple variables down here that you put them in parentheses. All right, how about this one? Let's try this. First of all, I have a couple more here. Let's try this one. Log base A of the cubed root of m squared. Okay, log base 8 of the cubed root of m squared. So again, remember whenever you have a root, you have to write it as an exponent. So let's begin with that. So we're going to have log base A of m to the power over the root. So 2/3. So let's simplify that. We're going to bring the exponent down to the front, log base A of m. Now let's take a little bit longer one that has a root with it as well. So let's take this one, log base B. Let's see, what am I, okay, let's do this one. So we're gonna do the square, we're gonna do an n root. So it's not a particular number, it's just an n root of x to the third, y to the fifth, over z to the m. So this one's a little more of a challenge problem. If you want to pause and try it, go ahead and do that. So the first thing that we're going to do is we are going to, first of all, get rid of this radical, and we're going to write it as an exponent. So let's begin with that. So we have log base B. So what we're going to have here is x to the third, y to the fifth, z to the m. And we're going to take all of that to the 1 over n. Do you remember when I said you can write it as 1 over n, or 1 over whatever that is? Way back, I don't remember where that was. I don't think I have it on this paper. But this root, right, it's 1 over whatever the root is. So that's why we do that. It's always 1 over whatever it is. All right, so now from there, let's go ahead and bring that down. Let's go ahead and use our power rule. All right, so I'm going to start down here. We're going to use our power rule. We're going to bring that to the front. So we'll have 1 over n. And then log b. And then we're going to have x to the third, y to the fifth, over z to the m. Okay, so let's keep going. We're just going to keep going, doing all the steps. So now we want to be sure that we bring these powers down, right? So we have these individual powers that are inside there. So let's go ahead and remember that a log b goes to each one of these. So we're going to start up top. It's going to be kind of a lot. We're going to bring the 3 down. We're just doing x cubed. So we're going to bring the 3, and then we have log base b of x. Okay. Now I probably need to put on the very outside here, we have this 1 over n. Okay, so that's still there. But now we're just working inside the parentheses, all right? So now this is a multiplication. So what does that mean? That means I'm going to add it. And we're going to bring the 5 down. So we're going to have 5 log b of y. Okay. And then now we have a quotient. So we're going to subtract. But notice I don't have to put parentheses because I just have one variable down here. Like before I had an xy, I just have z. So we're going to bring the m down to the front, log b of z. Now I just want to multiply this 1 over n and distribute to each one of those. So all this then becomes is just 3 times 1 over n would be 3 over n, log base b of x, plus 1 over n times 5 would be 5 over n, log base b of y, and then this times this would be m over n, log base b of z. And that's your complete answer on that. Oh, that's your final answer. All right, so I think let's take these now that we learned, and let's make these, write them as a single logarithm. So now we're going to write as a single logarithm. Okay, so that means we're taking the expanded form, and we're going to move them. We've got the expanded form, and we're going to move them, take them back to the single logarithm. So for example, let's say we have log base 3, let's say, let's go with x plus 2 plus log base 3 of x minus log base 3 of 2. All right, so first of all, recognize they have to have the same log base. So these have to be the same. Otherwise, you have to do something different. All right, so check into that first. So if we make this into a single logarithm, all we're going to do is, we have log base 3. We just have to write that once when we write the single logarithm, if you remember. All right, now we're going to have, what does this addition mean? It means multiply. So that means we're going to take an x plus 2 times x, right? X plus 2 times x. And then what does this subtraction mean? That's a quotient. So then we're going to divide by 2. And that's a single logarithm. How about this one? Okay, so let's take a look at that. So what is our log? Well, it's log base A. All right, so what does this mean again? When it's written as this coefficient, that's going to be an exponent. So that means we're going to bring that back up to n squared. And then we have a subtraction, which means quotient, right? It's our division. And then again, we have this coefficient that comes back up as an exponent into the third. All right, so that's writing as a single logarithm. So the last thing I wanted to do is sometimes we'll be given a problem to solve and we have to use what's called a change of base formula. And so on that change of base formula, and I noticed on Desmos, I think it has that base that you can put in there. So that's one of the newer calculators. But this is something that I would expect you just to show me on a test right now because not everybody has that calculator that can do the work. So what I would ask, so let's say, change of base is when we have, let's say we have log base A of x, okay? And we're not able, it's not a common logarithm, so we can't just type it in the calculator. That's when you know you need change of base, like if this is a 7 or a 4, something like that. So what you're going to do is you are going to put it in the calculator, but how you do that is you take the log of x divided by what the log of the base. All right, so for example, let's do an example. Let's say we have log base 5 of 17. Well, I can't solve that because I don't know 5 to what power equals 17, right? And it's not a common logarithm, it's not a base 10. So I can't just put that in the calculator like log 17 because it's got a base 5. So we're going to use the change of base formula. So the change of base for this is going to be, we take log of this number, so log of 17 over log of the base. So we've put those into common logarithms. So then if you put that into your Desmos, let me just clear those out. All right, so if we put that in here, all we're going to do is do our log of 17. Okay, divided by, oh, I did that wrong. Let me go back. I got to finish that off with a parenthesis. All right, and then divided by, see how that, I don't know if you saw that, but that was what would have been incorrect. And we're going to take log of 17 divided by log of 5. So I'm going to go back to log here of 5, put in your parenthesis. So it's going to be approximately 1.76. So that's how you can use your calculator to solve a log that is not a base 10. Okay, so let's go back here and take a look at, let's do one more here. So if we have, let's say we have log base 2 of 0.1. So we don't know what that is. We can't really figure that in our heads. So when we write it out, it's going to be log of 0.1 divided by log of the base. So if I go through and put that in the calculator, and you can do this on your own, it's going to be approximately negative 3.32. You can check that, see you can do that on your calculator. And that's change of base. Okay. All right, well that, you guys, is all of 6.3. So thanks for, hopefully you're tuning in and watching these to help you out, prepare you for your assignment and your final. And we'll be working on the next couple sections here soon. All right, have a great day.